Hi, welcome to part 21, Wolves on the BackBit. Yeah, this is it. This is the finish line. This is the part where I wrap up the project and I create that YouTube video of Commodore 64 captured audio and video output, basically showing what a year's worth of work looks like in a 155-second video. And so what happens in this episode itself? Well, there's one specific problem that kind of flew under the radar the entire time that I was doing this project, and it's not until now that I've really paid more attention to it. And now that I know, I cannot let it go. I have to fight it. I have to try my best to figure out what's going on, or at least find a way around it. And well, I do find a way around it, but it's not perfect. But anyway, that doesn't matter. This is the second last episode. Part 22 is the true end, and that takes place in the next little while. When I start making these videos, a few last minute ideas kind of compel me to implement them, and implement them I do. It does improve the final product, and I'm very pleased with that because, I'm kind of a perfectionist. Maybe you've noticed by now. Anyway, I've got a little bit of time to kill here. So, I do want to thank you for watching all these videos, putting up with me, putting up with, my shenanigans and stuff. It does mean a lot that you were with me on this C64 Coding Adventure. I didn't really know how this was going to turn out at the start. Surely I had no real plan. I'm fudging my way through it. I'm learning as I go, and it worked out. Huh. I'm quite pleased with it, and I huh, I feel like a kid again because the backbit has opened my eyes to the potential and the excitement of the what ifs and stuff. You know how it is when you were first programming, everything seemed possible. And it's not until you learn the limitations of the hardware that you realize that not everything is. But the backbit itself, in terms of what a Commodore 64 can do, has greatly increased its potential. And this project is, proof of that. It's a 12 megabyte file, 6 frames per second video, digital audio, and it's kept up at a steady pace for over 2.5 minutes. So it can do it. This is the type of thing that the backbit was designed to handle. And 12 megabytes is only 0.3% of the capacity of a BBT file. So that gives you an idea of programming potential, what you can do with this device. And thanks to Evie for creating it. Evie, thank you. I enjoy your product. I liked programming this little device. It like I said, it's opened my eyes to all sorts of potential, and uh, this hopefully was just the start. But yeah, I can't really make any promises. As it is, it took like over a year just to do this, right? But I also want to thank Jeff Birt for making his C64 DIGIs videos, which showed me that I too can make DIGIs on the Commodore 64. Good stuff. And I also especially want to thank Mahoney for coming up with his ingenious, elegant way of creating DIGIs on the C64. They sound so good. And if I ever do use digital audio again in the future, you know it's going to be Mahoney style. This stuff rocks. So, I guess that's about it. Yeah, without further ado, not even to show you how majestic I am, let's get to it. Part 21, the finish line. Let's watch.
This, I believe, is what I've settled on to save time. The old look for groups of 4 that aren't being referenced. There we go. And during the color writing to screen routine, it's pretty easy to skip if the first group of 4 is a negative. And, well, I haven't added this, but on the color, bring it in from the BackBit. Also, just happily skip when you have a group of 4 that begins with a negative value. I was getting 94%, just initially. It'll probably be a little better once I get the tweaks in to obey this on the way in as well. It'll be good enough. The border you see is the current background color for that frame. When it does reach black, that's how we know we're done, because it never becomes black except in that one instance of the blank frame at the end of the file. All right, watch the blue wolf and the other guys look for interference on their bodies. There's nothing, right? But if I take this same file and use my frame viewer program, all right, here's the real head scratcher. Look at this. Was that there before? Same 2 frames, different every time, wildly different. I thought I had corrupted my file completely, but this did not display in what you just saw. So why is it showing up all crazy here? Intermittently crazy, because like that's A, B, A, B, A, right? Different ones. Oh man. So annoying, but Super CPU is back in play. And here we are, same scene, Super CPU disabled. We'll go in 1 frame at a time here. No corruption whatsoever. I mean, I've gone so long using the Super CPU in this project for all sorts of things, like speeding up collective writes to the SD to IEC, making these huge files that ended up cramming into a BBT. It's just, wow. Right, the switch is in fast mode, and I'm not getting interference. This is an incredible head scratcher. However, I do believe I finally got the color cell skip flags in their proper place. But this just blows my mind, that the hit and miss nature of the speed, It's like, come on. Well, I just played my latest version, which brings in the color RAM somewhat compressed and plays it to the screen somewhat compressed. I haven't seen the results yet. I bet you it's 95%. Ooh, even better, 96. Well, that is it. That is the best I can hope for at this point. Yeah, not bad, but I'm pretty sure that's going to be done. So I get to go over my code a bit, make sure everything's nice and neat, and then sort of extract this stuff and create a single file that is used, on the final presentation, because I don't think the whole source should go with it. But yeah, 96%. Yeah, it's not a terrible failure, but damn, I could still improve it. I know I can. Should I? No, I shouldn't. Well, this is the couple of the final tweaks. This is the part that color gets written to the color RAM. As you can see, it loads 1 from the buffer, but if it's negative, it happily just jumps ahead 4, right? Which saves a bit of time, because this happens quite a bit. Now, the other version, or the other alternative, this one, actually, it's not for bitmap anymore. That's misleading. Let's see. Well, here, for instance, when it brings it in off the BackBit, it's got to save it to the buffer, and then, if it's negative, jump ahead. Because if it doesn't save it, how does it know to skip later? So it does have to save one of the 4 bytes, no matter what. But still, it's still quicker this way. And then I was running out of room because let's see here, my little debug pages also ran out of space. So I am now, each of these is only half a page. So, and the bonus is after 128 reads, for instance, what do we got here? The ear index. After it reaches 128 readings, it just forgets to do any of this stuff, which saves a bit of time as well. So, you know, the first 128 readings are legit, and after that, it just stops caring. Good enough. All said and done, I'm satisfied with my 96%. It's like, deal, take it, hit the button. It's disappointing as well because of all the time and excitement and, you know, I thought I could do it, and it's just too much. But the plus of it is, once I get to wrap this up and make a few videos, I get to move on to something else. You know, starting a new project is, well, it's a lot of fun because, you know, you're wide open. Anyways, thanks for watching all these, and have a good night.
Oh, the water always tastes so good here. Huh, if only they were here.
Might as well document one of the very last problems I'm dealing with. Check this out. I turn it on, and odds are the first run's going to be staticky.
Oh, the water always tastes so good here.
So, but when you run it again,
Oh, the water always...
right? One more time. Now I'm going to kill it with the button. Play it again. Sometimes, well, it's not going to do it. Sometimes the cartridge does not come back online. And it freezes with what's in memory because it won't ever fetch new stuff. But there we go. Why? But second time round sounds good. Right? I don't know. I don't know what the deal is. Here's another bad one. And if we reset the machine completely, first one's usually bad. Well, that's not cool, is it? Why? Thing is, I got so used to the run, change cycle that I was always hearing, the second time round, the 10th time round. That first time round, well, I almost never hear it. But odds are that's what the end user is going to hear the first time they run it, and they're going to get a staticky pile of crap, and they're not going to be impressed. I got to at least make some attempt to figure out what is going on with this thing. Does the SID need to settle? Like when you do the chip detection? I don't know. I mean, honestly, though, we are dealing with stuff beyond the design of the SID. So, I mean, this is something I have to at least give some attempt to try, or warn people that the first time is going to sound like crap. Or maybe put in a prompt, press return to play, and maybe that will give the SID enough time to warm up or whatever. I don't know. Even this doesn't seem to fix it. See? Oh yeah. Come on. I was just getting a bunch of crap a minute ago. There. Why, right? Get lost. Hit or miss. Now we have a new problem. I changed the BBT. Oh yeah, now you're working. Whoa. Well, I think I finally got my patch done. This problem of the static upon first play is really distressing. But anyway, this is an old program from Lodestar that takes, there we go. It links them together, and then when you run it, it puts the modules where they need to go. So I'm creating a single file that becomes the only file. See, I can change the load addresses, but this is exactly where they need to happen. So, what's it called? Oops. 1B. There we go. Good stuff. Okay, so the next steps are to take that file and actually make it the one that the BBT launches. Now, if they're static, I'll show you how I fixed it. Great, there is static. Let's listen. Oh, it's terrible too. Now, anything in the one column of the keyboard matrix, this one, I'm not sure about that, will break out of the program. But I changed it so this will run the refresh SID, which zeroes it out and gets it ready for the Mahoney thing again. So all I have to do is press it. Well, how do I get both in a shot? Here we go. Sometimes you have to press it a lot. There we go. Every time you hit it, it zeroes out the SID and resets it up for the Mahoney. The equivalent of breaking out of the program and running it again. And in many cases, it gets rid of the unwanted static. Not a perfect fix, but an acceptable patch. And if you press a different button, it breaks out. Ha. Oh no, I used the wrong basic file. I wanted the one that showed the SID stuff. Oh crap. Well, back to work. See, now what I did here is I restarted the machine, selected my usual BBT, but then I held the stop key so it didn't run. And then I'm going to reformat, so to speak, whatever's the disk that it's attached to. Now watch the light. There was a quick blink, so it didn't take. Sometimes it takes two. I don't know why that is. Maybe it's doing it to internal memory, and then when you do it again, it's like, okay, that means serious. Now watch this. Now it's really formatting. There we go. And then we get the new file, Wolf Player 1C, I think it's called, on my SD.IEC. It's on number 11. See, we're loading it in. And the difference here, well, I made a couple fixes, one of which is adding a small delay when you reset the SID between the zeroing and the Mahoney magic values. I don't know if it's going to help, but it can't really hurt. So here we go. So once again, now the light is blinking a lot. So it's actually saving. There. And that's it. So our BBT has been modified. So all I do, start from scratch. And now when I pick it, it's launching that latest version. Now, if they're static, then we're in business. And then I can show you how to fix it. Oh, terrible static. As usual, Commodore key. Ready? Helped a bit. More. Come on, you beast. I don't think that delay helped at all. There we go. That took a lot of presses.
It sure is pretty, but I could never bring May.
But I think after that, it's all good.
It's so shimmery.
Okay. There. And that's the version of the basic I actually wanted to get. I don't know if that delay helps between the zeroing and the adding the Mahoney stuff. Maybe I'll take it out. Unfortunately, I might have to just settle for the, where the user can hold this down to get all the static out of the system if they have some, instead of breaking out and SYS 32768 to launch it again. Because I was rather stressed, right? Now, if I quit, it gives me the option to start again. I was rather stressed out about, spending all this time getting the beautifully sounding Mahoney Digi working, only to find out that a good number of the time you're going to start out with it staticky, and I don't know why. I still don't know why. So this is more of a patch, but I was thinking, what if I just took the ordinary Jeff Birt Digi, that's less complicated, and re-encode my Digi file to spit out numbers 1 through 15 at the SID. I know the sound quality would be worse, but would it be susceptible to that static that you get when you on first launch sometimes? And I didn't want to have to go backwards, because this sound, like, listen to this. That is pretty good, isn't it? Yeah, sometimes it's a bucket of static and crinkle and crackle, but that's, I don't know. I don't know if this is a patch. It doesn't matter. It's not like this is a big release. I'm showing you at the very end a little bit of failure with my success. I feel rather bad about that, but I have to come clean and tell you this isn't perfect and not close to it. So this might be my future backup path if I ever do anything else that has digital audio, because you might want to have to, in the middle of a game or something, you can't just kill it and restart it. There's got to be a way to jumpstart the SID and hopefully weed out, undesirable static and noise.